if this number, the amount you calculate of this reactant, is greater than the amount you're given in the problem, you're given 12 grams, this is the limiting reactant. But if this amount is less than the amount you're given, then magnesium is the excess reactant. Okay? That makes aluminum chloride the limiting reactant. That makes sense? Okay? Well, that's fortuitous for us. It's a good thing, because now I can just start with the 12 grams of aluminum chloride, and basically I've set up the first two parts of this and half of this one the way I've already started when I was doing the limiting reactant. But instead of going to magnesium here, we've got to go to the product we're looking for, and that's going to be what is identified up here as a solid product. That's aluminum. So we're going to start then with our limiting reactant. This now, second, is where we're going to be determining the theoretical yield. What is the theoretical yield? And we have to start with the limiting reactant. Is it okay if I just signify that as LR for limiting reactant? Okay. So 12.0 grams of aluminum chloride. I've identified this as the limiting reactant because the amount of magnesium I calculated was less than the amount given. That makes this the excess reactant. If this is if magnesium is the excess reactant, only aluminum chloride can be the limiting reactant. You've only got two reactants here. So we start with this over 1. We already know the molar mass, and we've got it set up here the way I'm going to need it, 1 mole. If it wasn't set up that way, you could flip it. Okay, you set it the way you need to get things canceled that you want to cancel. Go ahead and cancel grams, cancel aluminum chloride, and now we're ready to get to the molar ratio. We don't have to balance an equation again, we've already done it here. In this case, we're going from the limiting reactant to the solid product. And the solid product we said is aluminum, so we're going to put the molar amount of aluminum chloride, the 2 moles of aluminum chloride on the bottom here. And then we're going to put the thing we're looking for, the aluminum metal, on the top. And we've got 2 moles of that as well. Alright, so we can go ahead and cancel now moles and aluminum chloride. And now we need a molar mass for aluminum. Well, we already know the molar mass, actually, because the molar mass of aluminum is its atomic mass written in grams. So aluminum then, 26.981538, and we only need one of them, so we're going to say that's grams of aluminum equals 1 mole of aluminum. So here's our equality statement we need for this conversion unit. We're going to put the 1 mole on the bottom here because moles of aluminum is what we have on the top here. We want to go cancel that. So 1 mole goes on the bottom. The mass then goes on the top. Alright, and we can cancel moles, we can cancel aluminum, and we're going to be able to calculate the amount of aluminum produced. Now this will be a theoretical yield, not a real amount. Okay, again, the way that I've taught you to put this in your calculator, because it's kind of fast to do it this way, is you're going to take the 12 on the top here and multiply that times 2 and then times this number. So 12 times 2 times 26.981538. Hit enter. Then hit the divide key and put in this number, divided by 133.341. Enter and divide by the 2. Okay, and I get 2.428198 799. Now, before I go further, you might have noticed that these 2's here can cancel. Okay, they can cancel. You could have skipped over that step, but you don't really have to remember that. Either way, you're going to get the same answer. All right. Now, we need 3 significant digits of the measured of the measured numbers and the calculated. These are 2 calculated numbers. Of the measured and calculated numbers, we have this one has the least digits. It's 3, so we want to round this to 3 digits. So we get 2.4. Now this 8 makes the 2 round up to a 3. And the species we have left, or the units we have left, is grams. The species we have left is aluminum. And so this number here is the theoretical yield. All right. I have a problem. I made up a number a while ago. Turns out we can't possibly have 9 grams of solid product because we only have a theoretical yield 2.43. So I want you to go back to your original problem. Let's change that amount. Okay? Instead of 9 grams, let's just say that we collected 2 grams of the solid product. Okay? 2 grams of solid product. Change that in your problem. Okay? Change that in your problem so it won't conflict with what we've calculated down here. I threw a number up here, and today I'm not feeling too well, so I didn't estimate very well. Okay? All right. So that's our actual yield. The 2 grams of solid product is the actual yield. The way we're going to find the percent yield, so the third step then is to calculate percent yield. Okay? And we're going to put, go ahead.
So theoretical yield is what's in the problem? I mean, like what you get out of the solid product?
Yeah, well, the theoretical yield is what is the maximum possible amount. I mean, it's not really possible. I mean, but it's the upper limit of what can be actually collected at the end. Okay? If you ever take calculus, you'll understand more about what a limit is. I mean, a limit, you never get to the limit. It's just like that stops you before you get there. All right, so what we're going to do for the percent yield is we're going to take the actual yield and we're going to put it over the theoretical yield, and we're going to multiply that answer by 100 to get a percent. Okay? Well, the actual yield is the amount you actually collected. In the problem, you actually collected 2 grams of the solid. And the solid we figured out from the balance in the equation and predicting products was aluminum. So that's 2.00 grams of aluminum. The theoretical yield is 2.43 grams of aluminum. 2.43 grams of aluminum. We're going to put that in a fraction. And then when we do that math, then we're going to multiply by 100 to get an answer. Please pay attention here because you should notice that these grams cancel. And just something that I've told you repeatedly, I'm going to repeat here, all percentages are unitless. If you don't set up your percentage calculations in a way that cancel units, you know there's something wrong. All percentages are unitless. They're not always species-less, but they are unitless. In this case, they're also species-less because we can cancel out the species. So now we're ready to do this math. Now when I put it in parentheses like this, it means I do this mathematical operation and hit enter or equals before I multiply by 100. If you're not careful to do that, you might get the wrong answer. So you want to take 2.00, divide that by 2.43 and hit enter, and then multiply that by 100. And I get 82.30452675. Going to round that off to the number of necessary digits. This is a division problem here with only 3 digits in both the numbers we're starting with. So I want 3 digits in the final answer. And I'm going to use an arrow. This is an operator. It actually shows that we're rounding. If you don't have the operator there, that's not complete. The answer is incomplete. So this is 82.3%, and you need to tell me what that percent applies to. This is 82.3% aluminum yield, or yield in aluminum. What now? Yeah, well, our answer is species less, but you need to tell me what the percent applies to. Okay, that's the yield in aluminum. Okay? Any questions about how to do mass-to-mass calculations? Okay? Well, let's practice then. Get out a sheet of paper, your test references, calculator, and pencil.
What is this called? Molar mass calculation?
Well, we're doing a molar mass calculation here. I'm actually doing a percent yield calculation, but it requires a mass-to-mass calculations as well. If you just took notes, I'll let you use your notes on this. If you just took notes, I'll let you use your notes on this. Let's see, do I want to do it that way? Because that's not the kind of thing I gave you just now. Let me give you something that's very, very similar here, okay? I'm sorry. Okay, 4 grams of iron 3 chloride is dissolved in water and reacted with 8 grams of zinc metal. And if 2 grams of solid product is collected, what is the percent yield?